So go ahead again, page 4 of your notes. We're filling in page 4 of our notes. A balanced equation tells you the mole ratio or proportion of reactants and products in a chemical reaction. So the only blank to fill in is mole ratio. Now, mole ratios tell you the relative amounts of reactants and products. Mole ratios are similar. We're on page 4 of our notes, Matthew.
Oh, that's why I was on page 4.
Mole ratios are similar to us saying, for me to make a ham sandwich, I need 2 pieces of bread and a piece of ham. Like, it's kind of telling us what we need to make our products. So mole ratios tells you the relative amounts of reactants and products. Now, mole ratios can be converted to masses, which you guys already know that, because have you turned things from moles to mass? Yes. So if we know how many moles of something we have, we can find out the mass of that object. Now, I do not think this is on the next page. I'm coming back. Don't panic. Yeah, it's not. Okay, that last blank is not on here. The coefficient in a chemical reaction tells you how many moles of that compound is in the reaction. So that is something that's not on the screen. I'm so sorry. I didn't realize that until just now. The very last blank says the coefficient in a chemical reaction tells you how many moles of that compound is in the reaction. So that very last blank that is not on the screen is moles. So what does the coefficient tell us? What does the coefficient tell us? Good. How many moles we have? Okay. This is a different practice than you've got, so let's do it first. Give the mole ratio for the following equation. Who would like to raise your hand and tell me which one you think this is? Give the mole ratio for the following equation. 2 mg plus O2 yields 2 MgO. Mika.
212.
Good. So we have, let me get out my pen so I can mark this for us.
This is not on paper, right?
No, this is just us practicing. We got some more practice on our paper that you're going to do in just a second. So we have, oh, nope, that's not a highlighter. So right here, we have 2 moles of magnesium. There's no number in front of oxygen, so that represents 1 mole. And then we have 2 moles of magnesium oxide. So our answer is C212. Does everybody understand how we got that? So on your test, on one of the FRQs, you will be given you'll be given a chemical equation. You will have to balance it and then tell me the mole ratio. Okay? Yes, ma'am.
On our practice on the thing, it has heptafluoride, but it's not heptahydride, but it's actually hexahydride.
Well, that's different. That's named different. Yeah, I'll have to tell you that in just a second. Sorry. Yeah, those are named totally different than what you're doing. Those are hydrates. Okay, than what we're used to doing. All right. Now, you can also know how many you need. So let's look at this one. How many moles of magnesium are needed to make 2 moles of magnesium oxide? So we have 2 moles of magnesium oxide. How many moles of magnesium do we need, guys? Everybody answer this. 2. Yeah, if I'm going to make 2 moles of magnesium oxide, I need 2 moles of magnesium. So my answer is A. Questions about that? Is this hard? No, it's not hard. Just remembering that those also tell us number of moles. Oh, and that's it for the practice there. I want you to do the practice in your notes really quick. And she mentioned heptahydride. So hydrates are named differently than what we've been naming. So the dicarbon heptahydride is weird. So ignore that first question. Just mark it out.
Excuse me.
Mark that first question out. I won't make you answer one like that.
Oh my gosh, I'm so sorry, guys. Alright.
But answer the other 3 questions under number 1, and then we'll check them. So ignore the first question, but answer the other ones. All right, so number 1, how many moles of oxygen are in the reactants? 7. How many moles of carbon dioxide are in the products? 4. How many moles of water are in the products? 6. Good. Number 2, I want you to answer number 2 very quickly, and then we're going to check them. Answer number 2 quickly, and then we're going to check them. All right, number 2, how many moles of hydrogen does it take to make 2 moles of hydrochloric acid?
2.
What coefficient is in front of H2? 1. 1 mole. How many moles of chlorine does it take to make 2 moles of hydrochloric acid? 1. Now let me ask you this question. If we wanted to make 4 moles of hydrochloric acid, how many moles of hydrogen will we need? 2. Good. That one will be a bonus question. The questions like this will be on your FRQs. But the one I just gave you where you have to infer will be a bonus. Number 3, go ahead and do it so we can answer it and check our answer. Now, before you answer any questions about moles, what would you need to check on? I'll just say y'all are all kind of correct. We need to make sure it's balanced. If your equation isn't balanced, then you can't answer questions about moles or mole ratio, okay? So always make sure they're balanced before you answer it. Number 3, in this reaction, how many moles of hydrogen are produced? 1 mole of hydrogen, good. Now answer number 4, and we're going to check it. All right, what is the mole ratio for A? 112. What is the mole ratio for B? 2746. Good job. Is this hard? It's just a little extra that we have to learn for honors. These are the types of questions that will be on your free response. You will have some on your bonus that go like a little bit further than this, but these will be the ones on your free response. Now, I need you to get out your atoms and periodic table learning target sheets, your bonding learning target sheets, and your Chromebook. You can put everything else up.